Okay, we're going to take a look now at the standard normal distribution. So this is still the bell curve that we looked at in the last YouTube, except now we're standardizing it. So what that means is we're taking we're going to standardize our scores so that whatever the standard deviation is and the mean is, we're going to take them back to a mean of 0 and a standard deviation of 1. As is noted there. So here's our bell curve, bang down the middle there. That's our mean of 0. Our standard deviation is 1, which means that that little area there under the bell curve will have an area of 68.683. Counts for 68.3% of the scores. Now, standardizing the normal distribution, standardizing scores within a distribution is going to be a really useful tool for us in order to solve some problems, and we'll look at an example in a moment. But I just want to firstly show you how to standardize a score. So if we've got right, here's the formula for it. Z being the Z score, or the standardized score, X being the score you are standardizing, and obviously mu and standard deviation being the mean, and so mu and sigma being the mean and the standard deviation of the distribution. Okay, as noted here. I don't know if I mentioned this in the last YouTube. This means X is distributed normally. So it's a normal distribution. And so our first element here is the mean, and the second element is the variance, not the standard deviation. So we need to square root this in order to get the standard deviation to do our work. Okay, so let's have a look at an example. The score 25 in a normal distribution of mean 15 and standard deviation 6. How would that read? So that would read, this is a normal distribution. Sorry, that's wrong. X is the random variable that's distributed normally with mean 15. This is how it would look. Standard deviation is 6, so it would be 6 squared, or 36 in there. That's how that looks. Okay, so how do we standardize 25, or what is the Z score for 25? So therefore, the Z score, which I think, all right, we'll use that language a little bit. The Z score, it means the standardized score. The Z score for 25 is, okay, Z equals X is 25 minus the mean, which is 15. So that just gives us the difference from the mean. So the difference is 10. We're now going to divide by the standard deviation, which is 6. So what this is going to give us, 10 over 6, or 5 over 3, or 1.6, is the interpretation there is that is 1.6 standard deviations above the mean. So the interpretation is 1.6 standard deviations above the mean. Okay, you can imagine if we standardized a score here that was less than 15, we would have a negative result, and it would just give us an indication. 1.6 standard deviations above the mean. So in this spread here, it's up here somewhere. You know, this is the score 25 in this spread where the mean is 15 and the standard deviation is 6. So it's a pretty useful score, the Z score. It's quite nice. Let's do an example. Okay, I'm going to look at an example. I'll pause while I write it out. Okay, here's my example. In a normal distribution, it is known, here's our distribution, our bell curve, that 10% of scores are above 5.2, and that the mean is 5. Okay, so I've drawn this in, my mean's 5, bang down the middle, 5.2 is there. I don't know what my standard deviation is, that's what I have to find out. But I do know that this area here, this area in here, is 0.1. 10% of the scores lie in here, it tells me that, are above 5.2, and that the mean's 5. Find the standard deviation of the distribution. Okay, so what I'm going to do, I'm going to find out what my, I'm going to find out this 5.2, what its Z score is. So, once I can work out what that is, then I'll be right. So what I'm going to do is I'm going to find out what my Z score is for a 10% area here, and I'll show you how that's done. I'm going to go in to my inverse, because I've got the area. I'm going to go into my inverse normal page, and I'm going to put in my area, not of 0.1 though, because that's the area to the right. I need the area to the left, don't I? So I'm going to put 0.9 in here, 0.9. Now I'm going to leave my standard deviation. See how my default values here are mean 0, standard deviation 1. That's my standardized my standardized normal distribution. So I'm going to leave it like that. I'm going to hit OK, and I'm going to get my result of 1.28155. What that means is that this number here has to be 1.28155, has a z-score of that. It's got a z-score of 1.28155. I know that because if this were standardized to 0 and my standard deviation was 1, then this would be 1.28, slightly outside my my standard deviation zone. Z-score is 1.28155. 5.2 is that's my z-score. How can I use that with my formula? My formula reads this: z equals my z-score I get from taking my score x, subtracting the mean, and dividing by the standard deviation. Now I know my z-score, I just found it out. So I used the area to get my z-score for my standardized normal distribution. Okay, so my z-score is 1.28155. My x, well, it's 5.2. Right, that's the score that's being standardized. My mean is 5. I don't know my standard deviation, but I'm about to find out. So I take that across, so I've got 1.28155. Sigma equals 0.2. So sigma, my standard deviation, is 0.2 divided by 1.28155, which is, I'll pause. Okay, so you can see I've calculated my 0.2 divided by 1.28155, and I've got 0.156 to three significant figures. 0.156. So that's my standard deviation. I've used my standard normal distribution, my z-score, in order to find it. So let's just see if that makes sense. If it's 0.156, then it would be 5 here. One standard deviation would be here at 5.156. 5.156. 5.2, yes, it's just outside that, isn't it? And its z-score is 1.28, so I'm just over a quarter of the way beyond the first standard deviation, heading out towards my second standard deviation boundary. So that's how to use the z-score. There's one or two other questions it's going to be useful for as well, but we'll see those in class, and we'll have lots more time to discuss those. I want to probably spend Thursday, Friday, and possibly Monday on the normal distribution, so that then we've got a little over a week to then round everything up for the exam, which will just be on semester 2 work. Okay, I'll see you in class.